Okay. So these are two old state assessment test type questions. The four hands that just went up a few minutes ago, how many of you, well, let's just ask from the beginning here. How many are taking the math state assessment? We've got 1, 2, 3, 4. Okay, 4 kids taking the math state assessment. Now, even if you're not taking the state assessment, this still applies to you, because what you're going to see is that your final exam will be made up of very similar questions to state assessment type questions. Okay, so like I wouldn't doubt that you'll see a question that looks like this. Now, to be honest, I haven't looked at the final exam since last June, so I really don't remember what's on it and what's not. But this is a very typical kind of question, and this question says, for the question above, in what section is it decreasing and nonlinear? All we would need to do for your final exam is change this to say increasing and nonlinear, or decreasing and linear. So it's very easy for us to take the same diagram, tweak it a little bit, and give you a brand new question. So you need to understand the points behind this question. For which interval of this function decreasing and nonlinear? Decreasing means going down. So follow me here. We always read a graph left to right. This is not going down. What is this doing? Going up. This part's going down. This part's going up, and this part's going down. So there are two down pieces. One is this piece, which is kind of curved, and then there's this piece that's straight. Which one is nonlinear? Ava? The curved piece. And if you notice, the curved piece begins when x equals -2, and it ends when x is equal to 0. So therefore, choice B, between -2 and 0. Okay? Any questions? Yes?
2 hours are going down.
Yeah, this just means it goes on forever and ever. It doesn't stop. Okay? We still read a graph from left to right. We don't like read this part from left to right and then over here go right to left. Graphs, just like you read a sentence, it begins on the left and it goes through to the right. Okay? As the x increases, the graph increases. All right, so now we get to the next one where it says that Jenny.
Whoa.
Hi, Jenny.
What?
Jenny wants to rent a truck for a day. Where are you going with your truck, Jenny? She contacts two companies. Laguna's Truck Rentals, charge $20 plus $2 per mile. Salvatore's charges $3 per mile. How many miles until they're the same? Well, you could do this a few different ways. You could plug in every choice and see which one works out to be the same, or you could solve an equation. The 2m plus 20 for 2 times every mile plus 20 has got to equal 3m for 3 times every mile. Opposite side, opposite operation, subtract 2m's from both sides, and I get that 20 is equal to m, so the answer is 20. Now, if you didn't do it that way, you could have plugged in the 20 and just see what it gets. If it's $2 per mile and you put in 20 miles, what's 2 times 20? 40. Plus 20 more makes? 60. And then over here, 3 per mile means 3 times 20. What's 3 times 20? 60. So they're both the same. That would not work with any other choice there. Okay, any questions? No. Okay. So let's talk English language here. I'm going to pause for a minute. Write down what you think the English word, just talking to friends, is the definition of scatter, the definition of plot, and then what you think the definition of scatter plot might be. Go ahead. Matt, let's get to work. God bless. Lenny, face forward, work on your paper. Right? All right, so let's talk about what these words mean, how it makes sense mathematically, and then the concept of a scatter plot, God bless you, as it applies to your life and decision making. God bless. Okay? So let's go through step by step and see what comes up with. What does the word scatter mean? Separate, okay.
Spread out, like everywhere.
Spread out everywhere.
I have a question. This word scatter. So let's say you think of scatter like seeds, and then you think of like plot as a plot of land. And then scatter plot would be seeds all over a plot of land.
Yeah, you just kind of scatter them here and there. All right, Davis, you had your hand up. Okay, yeah. Scatter means to distribute. Now, one case that I can think of with scatter is when you can think of like a pack of animals being hunted by wolves or lions or something like that, and the predators charge in, and then what do the animals do?
Scatter.
They disperse, they scatter, they run out. Yeah. All right, so that's an idea of what scattering is. And then now to plot means, to plot, one sense of plot means to design or scheme or something like that. But another sense of plot mathematically means to put it on a graph. So a scatter plot takes things that are spread out, dispersed, and puts them on a graph. Good, very good. Okay, so let's go to. All right. All right, so some key, I'm wondering why we're missing scan 2. I'm looking for it. Is this the next page?
Yeah.
It is, okay. All right. So it says some key characteristics of scatter plots. And then it says the point blank, usually perfectly on the line. And what you should put here is don't fit. Yeah, the points don't usually fit perfectly on a line. Okay, this is what we started talking about in class the other day. Consider what the words plot and scatter mean. Plot means put them on a graph. Scatter means they're kind of spread out. It doesn't say they're perfectly aligned. If I say to you that the predators scattered, do you get the idea that the predators are all in a perfect row?
No.
No, not a chance. If I take marbles and I scatter them across the room, do you think they're going to land in a perfect design?
Yes.
If they ever did land in a perfect design, I would start thinking that the person aimed them, that they were not randomly put. Okay? Now, relate this to this concept that we call the line of best fit. Now, Davis, slide over some more. You were talking to him. I don't care. Don't talk. Slide over. Is it possible some of these times that you talk it's innocent? Sure, but not all of them. Not a chance in a million.
He drops it
Don't just let him handle it. He's a big boy.
What if it's something important?
He's a big boy, Davis. He can handle it. It's his stuff. If you drop your stuff, you take care of it. He'll take care of dropping his stuff. It's like a parent was sitting here listening. If the parent was looking over your shoulder and they were watching this while you're on home watching videotape, I think the parents would turn around and go like, "What grade is this class?" I think the parents would go like, what are these kids in second grade? It's okay. So anyway, the good news is, the really, really, really good news, I think it's 240 teaching days left. 241 after today.
Do you like a calendar?
Yes, I do. Okay, now, how do you think this line of best fit works? Well, let me show you how it works. Ready? If you guys are good enough to figure this out without me, I'll show you.
Okay.
I'm figuring it right now.
But if you want to learn, then you need a little bit of direction. How many times when taking a test do you get upset or angry because you look up and you go, man, this teacher never taught us this. I know, what are they talking about? I never saw this stuff. Well, here I am trying to teach it. and you guys are the ones making noise. And I'll bet you some of you guys would be the same ones who swear I didn't try to teach you. Right? Now, scatterplot works like this. It plots all the points. Maybe we're doing something like this. Maybe I'm plotting a point that has the years that someone's been wrestling and the number of matches they win in a year. One thing about wrestling is the longer you've been doing it, for the most part, not always true, but for the most part, the more you tend to win. And the shorter you've been doing it, the less you tend to win. In the beginning. Now, once you've been doing it for long enough, you tend to win a lot. But there are certain mistakes you can make with wrestling that are gonna hurt you. So, another one I can think of is in basketball. Does it make sense that if you're really, really tall, you probably score a few more points in basketball, for the most part, not completely true, than someone who is really, really short? For the most part, not completely true. So what we do is we make scattered plots. Like, for instance, if this kid's been wrestling for 2 years, they win 4 matches. If this kid's been wrestling for 9 years, he's winning 9 out of 10. This kid's been wrestling for 10 years, he's winning like 9.5. So you plot all of these points for all of these different kids, and you put them in. And the first thing you notice is that they're not on a perfectly straight line. And we do not draw a line that goes like this. No, that's not a line. That's a squiggle. So what we try to do is summarize the data. If you said to me, who makes the best baseball? Who are the best baseball players in the history of baseball? I would say to you, a lot of the guys that I think are the best baseball players that I've ever seen are in really, really good shape. Get your knees down. They're in great shape. Guys like Mike Trout, guys like Yoenis Cespedes, guys like Derek Jeter, guys like all of these guys. But then there's Babe Ruth. Babe Ruth was, hey. He was a big boy. I don't know if you noticed or not, but Babe Ruth once missed a huge part of a season because he went to what they used to call back then a fat ball. Yeah, he got so heavy in the off season, and he couldn't lose any weight, that they sent him to a place to lose weight, kind of like The Biggest Loser on TV now. And that Babe Ruth got so heavy he couldn't play baseball. But Babe Ruth, if you ever watched him, he was a huge guy, and he's the best baseball player who ever lived. And he would hit a home run, and you'd see this really heavy guy going. If you watch the old videos, you'll see it. He's playing his thing. Actually, he even stole bases. And not only was he the home run leader, he's the best home run hitter of all time. Even though Henry Aaron had more, he had way more at-bats. He's hit the most home runs per at-bat in the history of baseball. When Babe Ruth did it, he hit more home runs as a person than all the other teams in the league put together. Incredible ability. Imagine that in a sport like basketball, where the leading scorer in the league doesn't only lead the league in scoring, he scores more points than all the other teams scored put together. That's what Babe Ruth did. He was just unbelievable. But he was also a pitcher. And when he was a pitcher, he was good enough to be in the Hall of Fame just for pitching, let alone for hitting. Truly an amazing, amazing baseball player. Now, what I would do is, instead of going from point to point to point to point to point to point to point, I just draw one line that kind of goes down the middle of all the points. And you know it's a good line of best fit if you have some points above, some points below, and the distance between them is more or less the same. Pretty consistent. Now, that's my line of best fit. If some kid turns around and hands in his test, and their line of best fit looks like this, are they wrong? No. Line of best fits, for our purposes, are not exact. They just have to run through the middle of the data. Now, one thing is, next year, you start using those calculators. And those calculators will actually compute the line of best fit for you. They'll tell you exactly what it is, okay? But for our purposes this year, we don't, come on, Frankie, move.
Sorry.
Help somebody out next time. Will you get your butt out of the seat?
Can I just drop off a couple of these for tomorrow's testing?
Sure.
Thanks.
Thanks.
What?
Okay, so, for our purposes, line of best fit, if I'm grading your paper and I ask you to draw a line of best fit, Michael could have a different answer than Ava and they can both be correct. As long as they both go through the middle of the points. Yes?
What happens if someone just like doesn't? It's like a.
Well, let's say someone does this, okay? Let's say someone draws this green line. Is that a line of best fit?
No.
No, because they're all on one side. But as long as it goes through the middle of the points, you're gonna be okay. And it's gotta be one straight line. It can't go
Oh,
okay? Now, the next thing that's important to understand is that there's this thing called a correlation. Now, let's talk about something that has a very, very accurate correlation, and then something that maybe is not such an accurate correlation. Does it make sense to every person here that the more time that you spend doing your schoolwork, for the most part, the better your grades?
Yeah.
Okay, so we would say that there's a very good correlation there, a positive correlation. As you do more and more schoolwork, your grades go what? Up and up and up. Let's say I wanted to do a correlation between the amount of sleep you've gotten and how your grades go. Now, if I sleep more and more, up to 8 hours, what tends to happen to your grades?
They go up.
They go up. If you sleep nothing at all, your grades tend not to be so high. Now, what if I was to instead give you a graph of the number of hours that you exercise and your weight? Does it make sense that the more you exercise, the lighter you get, the better
No.
shape you're in?
No, because you get muscle, and muscle weighs more than fat.
Well, let's assume that the person started a little heavy,
Oh,
right? If the person's in really good shape, you're right. But for the most part, most people are not starting in really good shape. So for those people, for people who never exercise, for the most part, they would start, as time goes on, their weight would be high, and then as time goes on, their weight would decrease. So that would be going down. And what that means is that there are two types of correlation. There's actually three types. The first type is called a positive correlation. This is a positive correlation, or a picture of one. And you know what that looks like? It looks like a positive slope. Now, what kind of slope is this? Negative. So not only is it a negative slope, it's also a negative correlation. So slopes and correlations look the same when graphed. And what kind of slope is right between positive and negative? Zero. And that means there's no correlation. For example, if I said to you, what is the correlation between someone's height and their grades in school? There's no correlation. You can be short and do really, really well. You can do short and struggle. You could be tall and do really, really well. You can be tall and struggle. Nothing about your height says, oh, now that kid there's a genius. And this kid here, it ain't having it. Height has nothing to do with it, okay? So there's positive correlation. That's whenever the line of best fit is going up. If the line of best fit is going down, it's what kind of correlation? Negative. And if it's just a straight line through the middle of it, and they're all scattered all over the place, then there's no correlation whatsoever. So, let's take a look at this lab experiment. Is this a positive correlation or a negative correlation? Positive correlation, very good. Let's take a look here. Is this a positive correlation or a negative correlation? Positive, very good. Okay, now the next thing to consider, and the last thing we're going to talk about today, is the correlation coefficient. Does it make sense that the more tightly packed toward the line, the more accurate the data is? Okay. So when we look at these, there are two positive correlations here. This is a positive correlation, and this is a positive correlation. They're both lines of best fit that I just drew. Which one looks like the data is more accurate? Everybody?
D.
D. So we would say that this has a correlation. I was reading and I lost track of what I was doing. Correlation, that's an L. Coefficient. A perfect correlation coefficient. If every single point is exactly on a line that's positive, would be positive 1. That's a perfect correlation. This one here is pretty close. It'd probably be like 0.9. Because aren't they almost all on the line? They're all very close. This is still a positive correlation, but they're nowhere near as close. So this one might be 0.65. Okay, it's not terrible, but it's not as tightly packed. Now, what kind of correlation coefficient is in D? Negative. And if this guy is 0.9 and this guy's 0.65, what would you think this one would be?
0.8.
0.8, 0.85, right? It's almost as good as this guy, right? But not quite as good. So let's say 0.88. Close enough. What about this one?
0.1.
0.0.
I don't see any correlation. You know, I could go this way, I could go this way. When that can happen, I go straight across. And that means there's no correlation. Now, if I have points in a row, like this, that are perfectly on a line, this would be a correlation of negative 1.0. If I have ones that go like this, and they're perfectly on a line, this would be positive 1.0. Is it possible to have a correlation that's greater than 1? No. If it's perfect, it's 1. If it's not perfect, it's close. Right, here it is. Very close, but you don't get bigger than 1. Likewise, is it possible to have a correlation coefficient smaller than negative 1? No. Negative would be perfect. Negative 1 would be. Okay, any questions about that?
No.
Okay, so what you have for your homework for the rest of the period is some review, and then also some questions about correlation coefficients and so on and so forth. You can get started on them now, stay in your seats. You've got, what, about 5 minutes, 6 minutes to get started?
What's the math sheet exam?
I'm sorry?
What's the math sheet exam?
When is it? I want to say it's
Next month?
either the last couple days of April or the first couple days of May. I used to know, but I've forgotten. I'm not really that worried about it. It doesn't really affect what we do.